All right, I think we're starting to settle in. I'm Kent Nebergall. This is Grand Challenges and Vast Opportunities. What I'm more going to talk about is how the next technology revolution with new space is going to happen, some reasons why it's going to happen. We're going to start out by breaking down the anatomy of technology revolutions in history and show essentially why this is coming to be. So this is human history pretty much in a nutshell. What we have is oh yeah, this'll, sure. I have business cards. So basically, you start with human power, animal power. What you notice is that each energy system is getting more and more intense and more dense over time. You also see a bunch of inventions that come around the same convergence. These are more spread out, of course, but as you get further down, this from here to here is only 200 years. This is about 2,000 to 500 years, depending on how you slice it. And then we also have this information jump that seems to happen with each boost. The ones in brackets are kind of coincident. They're not actually, we didn't need petroleum to make radio, but they just happen to happen around the same time. So we have three ingredients of what a technology revolution tends to come down to. We have energy, higher density, affordable, consistent, and safe. Invention, the capacity envelope or superpowers. Any invention which does not make things faster or more powerful or do more with less is generally going to be considered just a novelty. We tend to want our inventions to give us, Superman-type abilities as a human race. Then the other thing is factorial complexities. 2 factorial is 2. If you have A and B, you have AB. So you have 3 different, and BA, you've got 4 combinations. 3 goes to 6, 4 goes to 24, 5 to 120. This is a lot more powerful than just exponential because every combination and combination of combinations within that group is incredible. Is basically every invention you add into the pile is like adding as many inventions as are already in the pile times that. So again, whoops, wrong button. Information, science drives engineering and engineering drives science. If you have a better engineered microscope, you can discover things to do better engineering. If you do better engineering, you can make yet another microscope. This left and right foot as we advance in technology. Communication drives factorial expansion as well because we know how to make these connections if we talk to each other. Affordability drives all of these. The more affordable they are, the more people can do them, the more companies can do them with lower financial risk. So all these become magnifiers. And then finally, excitement. Nobody wants to work on boring tech. It's just not going to happen. You can work on it, but you're just going to hate every day of your life. So we have superpowers, comfort, and novelty. These are the 3 things we drive. Comfort and novelty is, video games are a bit of all 3 of those. The other thing is that, so we get these explosions in growth, these exponential growths, but it's not really exponential. Logistic growth looks just like exponential until it doesn't. We had the same thing with the space program. We went from Kitty Hawk to Apollo 11 in 66 years. In the almost 50 years since, we've done nothing remotely like that. Eventually, it just becomes the new normal. You had this Cambrian explosion of life in the prehistoric eras, but eventually that just became the ocean. That became what was normal. So you have these explosions, but you also have these plateaus at the top. And then these plateaus, when they become the new normal, they become the platform for the next emerging technology. So we're still using, with SLS, 1970s technology. It just costs even more than it did in the 70s. Even adjusted for inflation, it's just nuts. And then, so new space comes along and says, oh, well, we'll work on a better version of all that sort of thing. So what does that mean for space settlement? I think we're going to have 3 major waves. This one's already starting in a way. We have heavy, affordable rockets coming on with Falcon Heavy and so forth. We have this constellation of low altitude, high bandwidth satellites that are going to be coming on in the next few years. They won't be for everybody, because if you live in the middle of a building, you're not going to be able to put up a dish like that. But the collective ability of something to essentially replace your satellite cable and all that stuff with very high bandwidth anywhere in the world. You could have, watch Netflix in Antarctica in 4K on 20 screens on one dish almost. Then commercial crewed space. We're going to be launching crews on not only Dragon Rider, but also on the Boeing equivalent, on the Dreamliner, whatever they call it. Then once we start getting into the idea of routine crewed missions to the moon, early Mars missions with crews, deep space commercialization with asteroid mining and so forth, and then eventually we started getting into settlement. This is my grand challenge, essentially periodic chart table. These are the things that are being worked on in more detail now. We still have some problems here. This is what I was talking about in the talk next door just about a half hour ago. Eventually we get into all these issues with Moon and Mars landing. Deep space, we need to deal with these if we go anywhere beyond Earth. These we need to deal with Moon and Mars. And then with settlement, we need to be able to be independent. So in the years since then, I've kind of brought it into that whole chart is basically a grand saga, not just a grand challenge. And the individual challenges have different, for lack of a better word, key performance indicators. How well are we doing at each of these technologies? When all these lines start to converge around something where we have the ability to do that challenge, then we get that convergence that allows, that empowers and provides the platform for the next technological wave. But you notice the wave doesn't start immediately. There's a slow ramp up. It starts to get exponential about halfway till the next wave, and then it starts to level off again. But if you play your cards right, those indicators will be converged at this line about the time that you need them to launch the next economic wave. And right now, we're funding it from previous waves. This is largely internet money in terms of Jeff Bezos and so forth. So what does that wave look like? We've got Falcon Heavy coming online this year, Crew Dragon Starliner, that's the name I was looking for. New Glenn, NASA's working on some nuclear projects that use low enriched uranium for surface power that are pretty interesting. The low latency constellation I talked about, Bigelow's talking about 2020 for a launch. We've got other seemingly unrelated, but remember the convergence thing I told you about, AI, quantum computing, blockchain. Falcon 9 Block 5 is going to mature to the point where they want to be able to launch it practically every day. We're going to have 50 metric ton, the ability to launch 50 metric ton satellites for a third the price that we launch our 20-ton satellites. And possibly better, because that's not even counting reusability. So what does that do to the satellite industry? And it's actually a good thing that it's good for Falcon Heavy that New Glenn exists. Because if I'm a satellite manufacturer, I'm not going to bet all my stuff on one horse. I want to be able to say, oh, and if this just doesn't work, I want to have a backup plan. So I tried taking all this data and I started making a whole series of slides, and it was like, this is going to get really boring really fast, and this is all you really care about. What are the strengths, weaknesses, opportunities, and threats for each of these things in this space? Affordable launch, we've pretty well gone through most of these strengths. Weaknesses, we could have a regulation wave, we could have launch failures, we could have NASA budget cuts. Surface suits are not really being addressed right now. NASA spent $750 million on surface suits for Constellation. Have you seen one? I mean, we've seen pictures of them, but the spacesuits that are on the space station right now are leaking water. We're not even sure they're going to last as long as the space station. And we don't have a replacement, despite spending $750 million on a replacement 10 years ago. I mean, this has got to stop. They're getting serious about nuclear power, that's good. Opportunities for small startups, maybe life support, plant growth, getting ready for that next wave, image processing, AI for rovers and so forth, small cap and other smaller companies, surface suits, sensors, habitats, mining. Threats, if the money from aerospace, when the microchip was developed, suddenly we started putting billions into the computer era. we weren't putting it into space anymore because we kind of already picked all the low-hanging fruit. If AI becomes the new low-hanging fruit, then that investment might get deferred away from new space and into AI, into self-driving cars and things like that. So that's a possible investment flow issue. And then there could be an economic setback, and then there's what's called the chasm, which is you get really good at something and then suddenly there's a gap, between the startup and then becoming a mature market. So that gap may be once SpaceX burns through all its backlog of launches from the 2 launch failures, who's going to buy the next mission? So if we get through all 3 of those waves and it matures, what does the solar system look like? Well, for humans, we'd probably tend to stick around the inner solar system out to the asteroid belt. Beyond what we do, we could have human outposts, you'd be able to go out to Titan and so forth. But you'd also probably more than that have telepresence. You'd be able to say, okay, I'd really like to look at this thing on Triton. And I'd tell a robotic base there, okay, go map this space and set a robot there. So it maps it all in great detail, sends back the data file. Then I could go into a VR room. I could walk around that space and say, okay, I want to do this, 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 and this. Send that data file back to the base. Then that base comes back and says, oh, here, I physically went and did everything you said. This is what I saw when I did it. So it'd be a way you could explore, the whole solar system from your living room, practically. And then beyond that, what about artificial intelligence systems that use cryptocurrency type arrangements to buy and sell things across the system without human intervention? So you'd have an artificial intelligence economy that would cover the whole thing. Within that would be a more human-based economy, and then finally the place where humans actually live. So what are the strengths and weaknesses of that arrangement? With the AI economy, you can expand our economic model well beyond our biological limits, which is something that's never happened before, except into cyberspace. So you could have a world economy that is so rich that we could afford to do things like starships or deep space exploration beyond that, or set up larger bases where you just move in and there's a huge base there already built by robots. We no longer have the issue of we have the multi-planet species insurance policy and so forth, no longer threatened by natural disasters. Opportunities, obviously, just amazing economic growth doing something like that. Weaknesses, we're in a global era now where I can take a pencil and I can show you how all the parts were made in different companies and different countries and different materials and so forth. If I go to Mars and I try to make that pencil, I can't do it because I can't build things from 20 different countries when I'm in a base. So we have an globalist tendency in our first wave of space settlement and second and third. Beyond that, what happens when we actually do have an economy that spreads across the entire solar system, even well beyond our human potentials? There's a drawback to globalism in that you can't do anything for yourself anymore. You become very dependent. And you don't want the whole solar system to be one big daycare center where you're stuck as the infant. So this empowerment could also be very disempowering if it gets to a certain scale. When it comes to artificial intelligence, we've already had, will the AI rebel? I know that sounds like a weird idea, but we've already had things where we had like stock trading things where the computer wasn't told there was such a thing as certain policies that were illegal. So it just invented them because they worked. And it was like, no, you're not supposed to do that. You're going to, it's like, well, do we sell the AI to jail? Well, not right now. It's just a computer program. Did we send the programmer for it to jail? No, he didn't know the AI was going to do that. It just invented it on its own. So where do you go from there? I mean, we could theoretically get for lack of a better word, sid nature out of an AI, even if we did that perfectly. If we have AI-enhanced human beings, we're not going to get that nature out of a human being. We'll definitely have fraud in those circumstances. So if I'm an AI at Triton, in that scenario I painted for you earlier, what if I say there's some valuable material in that thing? The markets get speculated up until we find it, no, it's not verified, and then it drops again. And I'm buying puts and selling options on that. I'm a very rich AI at that point. they could be gaming us and we wouldn't even know it if we're not there. So these are the various threats economy, so it's going to be kind of like it is now with a global system, except on a much, much larger scale. So there we have it. Any questions? Yes.
So I'm interested in your focus on cryptocurrencies as the new financial system for the solar system.
I think we could have something like that. I touched on that last year in a talk. I just kind of buzzed past it because it wasn't really a thing. It wasn't the focus of this talk. It was 20% of my talk last year. It's something where if we can do essentially proof of stake type things, it's a way to transfer value from one planet to another without having necessarily a common currency. So it's evolving so quickly that if I made a statement on it right now, it would be obsolete within 2 years. I've got a wonderful slide that, you remember that I showed a slide that showed the entire history of, I've got a whole slide that's not, it's money in one slide. Everything from cryptocurrency to barter to everything. And if you go on YouTube, you can see the talk from last year. Yes.
And what you said that globalism on a larger scale is a weakness, but a lot of folks are saying that international cooperation can reduce the price to each nation, so I don't quite understand why you list that as a weakness.
When you make a system that's integrated, initially it's like putting bricks in a wall, but if it becomes more fragmented, it's more like dominoes. If one thing breaks in one place, the whole thing breaks. That's the issue we have now. If there was a major war or something, we're so entangled right now that any disaster anywhere becomes a disaster everywhere. I mean, we're going to be paying for a hurricane that just hit Texas because we're engaged and locked together as a country, as a single economy. That's great for Texas, but 200, 300 years ago, if something happened 1,000 miles away, it wouldn't affect you.
I guess I don't understand your definition of globalism.
Globalism, in this case, I'm talking about when you break down economies of scale into different locations to the point where you can no longer do something that is mission critical to surviving in one location. So things are going to be the first 3 waves are going to be, for lack of a better word, very Amish. You will have to be able to do everything within a relatively small space, except for what you import in terms of technology. So you'll get your new iPhone from Earth, but all your food, shelter, and clothing, all your minimums for life have to be done locally, because you can't have a situation where you're utterly dependent on not having a launch failure on Earth, 3 years ago, screwing up your ability to survive beyond a certain point.
Very complex issue.
Yes. Did you?
Please expand on the idea of next generation programs.
Good one. It's actually different slide in a different deck. But the idea is that any place where there is a lot of money, there will be dead wood that will find that money. Go to a company that has big defense contracts or big contracts on something, and there will be somebody who finds a way to spend that pushing paper instead of doing what the deal is. So NASA was able to go to the moon quickly because they didn't have a chance to build up that bureaucracy. Lately, it is the bureaucracy. So that's pretty much the point. Now imagine that on a solar system scale. We would have to engineer the economy from the ground up to not have that as best we could. Any other questions on?
And when you say engineer the economy, there are many folks that would be very scared at that concept.
When I say engineer, I mean, again, that was the talk from last year. How do you make an economy in such a way that it does not attract deadwood and cronyism and stuff like that? How do you make it how do you lock in the libertarianism? Not have a command economy or something like that. And again, with AI, that gets really scary because the AIs can do it behind your back and you wouldn't know it.
Would the distance from the solar system help that in any way, that you can't order something immediately, so that would add a lag to it to avoid some of that?
It does for the first about 50 or so years, but eventually once you start distributing the means of production across the solar system, and you increase the velocity of being able to move things around at lower energy levels. As you have, let's say EM drive works, that's a major ability to move things very quickly from one point or another. The speed of light is going to be a limiter at all times. So there's going to be limits on it. But if you can do it locally, or you can, it will eventually, again, it will go to a new normal. And you may have to wait a while for the most advanced quantum computing system, but it'll be baked into the pie as far as people are concerned. Yes?
Some of the current societal problems are inequality, shortage of maybe water at the future day, and cybersecurity. What kind of problem, societal problem you see once we are in this space?
In the near term, it's going to kind of take some of that stuff down, because we won't have as much waste. You can't waste a lot if you're on a space station, because there's nothing, there is no outside to bring stuff into it other than shuttles from Earth and so forth like that. So it pushes down on our negative, wasteful attitudes. It pushes down on our prejudices and so forth when you have to work with the same people, same 6 people day after day. Eventually, once it gets to a larger level, you may have more. We will eventually get to a point where we have the same problem, just on a larger scale. And this is repeated throughout history. The Roman Empire is a metaphor and so forth. My bigger concern is that right now, for example, we get very upset if we are not 70 degrees all the time in this country. We get very upset if we have a certain energy barrier around our comfort that we've become dependent upon, And we're spoiled brats, and I'm not talking about America, I just mean civilization in general, compared to previous generations. The initial waves of space explorers will not have that. Eventually, they'll get there. And then what? And then they'll have AI that's kind of, oh, well, we'll do that for you. Eventually, you might get mollycoddled into being useless. And there's a great book called The Machine Stops from 1907, I believe, by E.M. Forrester, which is everybody lives in a little cell, and they have everything they need the minute they want it. But eventually, the machine that gives them all these things starts breaking down. And it's written 110 years ago, and it's a perfect metaphor for the way my 8-year-old lives his life. So, any more questions real quick? Okay, thank you.